Okay, good afternoon, everybody, and welcome back to Sunoikis Digital Classics Summer Term 2022. Today we have our 9th session of this semester, and I'm very happy that today we have a session about natural language processing for historical text. Last year we were unable to have this session, but today we have our guests, Katie McDonough from the Alan Turing Institute and Ludovic Moncla from the Institut National des Sciences Appliquées. I always apologize for my mispronunciation. But so today we're very happy to have Katie and Ludovic as our guests for this session. As I said, so the title today is Natural Language Processing, NLP for Historical Text. As usual, you have a complete class outline in GitHub, a full description of the session with readings, and then also an exercise. And today, the session is for introducing geoparsing for historical text in French using NLP methods. So this is really, in our program, this is an interesting session for, again, for historical text and historical languages. So Katie, Ludovic, thank you very much for joining our program and for teaching our session today. And also one last thing before starting, so for our audience, you can use the chat in YouTube. Please ask questions, add your comments in the chat, say hi also, please. And of course, we will try to answer your questions during the session or at the end of the session. Okay, so I think we can start. And Katie, I think you are the first, or the floor is yours. And you should only unmute yourself because I can't. Okay, excellent.
That's great. So yes, welcome. We're very pleased to be here. Shall we go ahead and share my slides? And I'll just quickly say, so we're going to get started with a kind of introduction, and then we'd like to open it up for some initial discussion that's based on the introductory material and the readings that we shared with you. Then we'll move into the exercise with the Jupyter notebook that we've prepared. Ludovic will be talking us through that. And then at the end, we'll finish with some more discussion. And of course, we welcome your questions throughout. So yeah, so I'm going to dive right in. We are going to be talking about some research that we do as a part of the Géode project. So Géode is a project based in Lyon. It's co-directed by Denis Vigier, who is a linguist, and Ludovic, who's with us here today, who's a computer scientist. And we are a team of myself, a historian, a geographer, and some other linguists and data scientists. So it's a very interdisciplinary project, the goal of which is to study geographic discourse in historical French encyclopedias. So today we're only going to be looking at the first encyclopedia that's part of our collection. And this is Diderot and d'Alembert's great encyclopedia, Encyclopédie, which was published in the middle of the 18th century. Diderot and d'Alembert's Encyclopédie is a really important text for the Enlightenment. It includes 17 volumes of text published between 1751 and 65. And the thing that interests us most intensively in this project is the articles that were classified as geography articles. And that's a full 21%, about 15,000 articles in the Encyclopédie are geographical in nature. Who was writing these articles? In the first couple of volumes, Diderot, the sort of main editor, wrote a great deal of them. Many of the articles are actually unsigned in that we don't know who the author was. But once we get to kind of about a third of the way through the production, it's clear that one of the major contributors to the Encyclopédie, the Chevalier de Jaucourt, becomes the main author of most geography articles. And that remains true until the end of publication. So one of the things that really interests us in terms of working with the Encyclopedia is the opportunity to develop computational methods for working with humanistic information. And one of the things that's quite exciting for us is in particular to work with French text. So when we first started working with historical French text, there were really not that many resources around for doing natural language processing or GI science tasks with historical French text. And Ludovic is really a pioneer in this area, so we're lucky to have him here with us today. And the exciting thing is that even since we started this work, that has started to change. And it started to change not just for French, but for many other languages. And the thing that's quite exciting about historical text in many languages, as you as classicists will appreciate, is that language can present all kinds of complexities that computer scientists really won't have solved, in the sense that basic tasks in natural language processing and GI science are actually much more difficult to address with this kind of different data. It's historical, it doesn't conform to modern linguistic patterns, it might include languages that don't even exist anymore, and it communicates information that might not be communicated in the same way as it is today, especially in the kinds of texts that tend to be studied in computational linguistics, like social media data. So here, what you can see are just an example of one of the issues that we face that we'll be talking a little bit about today. On the top is an article from the Encyclopedia for a place in Illyria, potentially on the island of Crete, perhaps in Thrace. So Lissus is a place that the Encyclopedia includes an article for, precisely to call into question, to raise the debate of the location of this place. And this is one of the things that we thought would be interesting for you as classicists, that the Encyclopedia is a site where there's a great deal of discussion about the nature of ancient geography, the locations of these places, and of course, who the authoritative authors are that are making claims about the nature and the locations of these places. And so it's very, very clear to us that the information about Lissus that's contained in the Encyclopedia, as well as the way that it's written about, right, this kind of rhetorical strategies for communicating about place, are very different from the way that we communicate about what might be the same place today. So below, you see an article for what is certainly at least one of these sort of attestations of Lissus from Wikipedia. And so one of the things that we, of course, really struggle with in trying to translate historical information about place into machine-readable data is that we often lack resources that account for the complexity of the information about historical place, like in this example. So the second piece that we asked you to read is one of our efforts to really think about how we can overcome these challenges that have to do with locating quite vague, very ambiguous places for which it might be actually impossible to locate them according to one set of geospatial coordinates. And we did this by translating the place names that are mentioned in the geography articles of the Encyclopedia into a graph, right? So we're using network analysis to kind of examine the qualitative relationships, the topological relationships between place names, rather than their geographical or spatial relationships. So we're going to say more about that and show you how we did that later on in the notebook. But I just wanted to give you a sense of some of the ways that we're trying to open up the toolkit that humanities scholars and data scientists have for working with very complicated historical data. So just wanted to end this introduction with a few comments about the ways that the Encyclopedia engages with the classical past. So first of all, geography articles describe a number of those kind of celebrated places of antiquity, especially those that are discussed in well-known classical texts. Indeed, there's a really important subset of biblical places that are described in articles. And importantly, geography articles are a vehicle for communicating biographical information about famous people as well. So there's a really interesting kind of subcorpus of articles in the geography class that are actually biographical articles, and a number of those are about classical figures. And as we saw with the Lissus example, the content of these articles includes debates about the spelling of toponyms in one or many languages, and the location of these places as referenced by historical and modern texts and maps. So it's a very interesting site that captures debates about the geography of antiquity around the world in the 18th century. And so it's quite interesting for us to speak with classicists to see if that's actually an interesting, what has changed in terms of our understanding of the locations and the histories of these places from the 18th century to today, and the way they might be written about in places like Wikipedia. All right, so that's it. I'm done with these slides. And I'm going to turn it over to, before I turn it over to Ludovic, I just want to open it up to any questions first, and then second to just a few, then I will turn it over to Ludovic, and we'll get to the first questions after we open up the notebook. So yeah, so any initial questions based on that presentation? Anything I can clarify? Nothing yet?
And one thing, so for the languages, so French is the main language. Of course, we could see entering Latin. Are there other languages in those entries?
Yes, so there is a smattering of Latin and Greek and English, and mostly in the Encyclopedia texts. It's quite difficult for us to extract that, so to speak, but that would be a really exciting thing to work specifically on. And we're going to be showing some examples of the discussion of places in kind of the broader Mediterranean, but understanding when different languages are being used is a really interesting question, and of course, like why that's happening.
Yeah, exactly. This is why I was asking. Okay.
Yeah.
I don't know.
All right, so I'll hand it over to Ludovic to open up the notebook.
Thank you, Cathy. Yeah, so on the GitHub page of the course, you have the link to the notebook. So we prepared a little tutorials to use the named entity recognition tools. So if you open if you go to the notebook, so it's another GitHub repository, and you can, so you have some instructions. If you get used to program in Python, you can set up your own environment, and you can run the notebook on your computer. Otherwise, you can also run the notebook in a Google Colab environment, for instance. So it's what I will do for the tutorial now. So you just have to run and connect to the environment. So in this notebook, you have some explanation about what we do and what we will do in the session, and you have, of course, some cells of code that you can run and see what's happened. So as Katie told us just before, we are working with the Encyclopedia. So it's a use case to show how we can process files and how we can process texts to create a map based on the names of place names that we can find on the text. So we will see some examples of libraries, of Python libraries that can be used for this purpose. And the first one is the Perdido library, which is a custom library that we are developing on the Geode projects that Katie talked about. Also, we will also compare the results with Spacie and Stanza, which are some well-known libraries. So in this tutorial, we will load the dataset from the Encyclopedia. We will have access to the volume 7 of the Encyclopedia, which is about 3,000 files or articles. We will see that. I don't know, maybe Katie, if you want to say something about the discussion.
Yeah, I'll just wanted to say a few words about sort of how we're getting started, and to sort of I'll say a little bit about each question, and happy to answer questions that you have and comments that you have about these questions. So the first is to really highlight that what we're doing here is actually two separate tasks. So geoparsing is the combination of geotagging and geocoding, and very confusingly, different fields have many different names for these things. So please just let us know if there's something that you're like, is this the same thing as X? Then we're happy to answer questions about that. The jargon can be confusing. So in the past, geographic analysis of historical texts really focused on English language texts. And so, as I mentioned before, there's quite a lot of development that has been happening in NLP, and sort of the development of Spacie and Stanza are really good examples of the kind of explosion of multilingual resources in NLP. So the thing that we're quite lucky to have is the Encyclopedia text as structured XML TEI data. So some of you will have undoubtedly heard of XML, and maybe fewer of you will have heard of TEI, but TEI stands for the Text Encoding Initiative, which is a series of guidelines that helps people describe text so that the metadata about words and phrases and documents is machine readable in XML. So a lot of the information that we are able to query in the remainder of the notebook is possible to do because each article that we're working with from the Encyclopedia has article level metadata. And it's just important to say that this metadata and the text itself was created manually by the Artful project, which is based at the University of Chicago, and they're kind enough to share this data for this tutorial and with us for our research. And so just to kind of come to the discussion, the input-output question of what do you start with and what do you get at the end is really quite essential. As a lot of people will say, I would like to geoparse this historical text, and they're starting with a book that they have image scans of, right? So there's quite a lot of work that goes into creating, preparing and curating the data that's required to do geoparsing. And we're very lucky indeed to have Encyclopedia text already as structured XML data. What do we get at the end? Does anyone have an idea of what kind of data, what kind of format we're going to export from any of the geoparsers? What's our goal here? What kind of data would you like to have? I'm putting everyone on the spot for the first time. Any ideas? Do we want an Excel spreadsheet? So I'll just, to answer the question, I'll just say that the thing that we are able to get is structured data in a variety of formats, depending on what your end goals are for that. It could be a CSV, it could be GeoJSON. And because geoparsing does usually end with trying to create a map. GeoJSON is an incredibly important and useful format as output for a geoparser. So the other discussion questions, especially the next two, are really sort of poised to help think about geoparsing as part of a much larger ecosystem of work in natural language processing and in GI science that are both looking to think about new ways of working with geographic information in texts and to improve those methods over time. A lot of what you're going to see in this notebook will demonstrate the challenges that we continue to face in trying to identify place names in text and in trying to assign geographic locations to them. So I'm going to skip over question 4 and because I think we might come back to that in the final discussion. But I just wanted to open up the floor to anyone who has, ideas for what kinds of research questions we might answer using the results of geoparsing. So if you have a map of all the place names that are mentioned in a text, what kind of questions might that allow you to answer, either for the encyclopedia or perhaps for a text of your own choice? Just see if there's any ideas out there in the room.
Well, as the students have a several second time lag and may not reply on YouTube very quickly, I'm thinking in the encyclopedia, historical geographical biases. So if the encyclopedia is focused on places from a particular part of the world, like much more on Europe than on Asia, for example, or
exactly, and that's definitely one of the things that we're quite interested in is really kind of the history of how geographical knowledge is communicated and how that changes over time. And so being able to compare encyclopedias over time allows us precisely to see how that bias in coverage is changing, at least in French publications. And ideally, one day we'll be able to compare that across reference works in other languages as well. So yeah, that's a great example.
And then I think you mentioned that there is a debate in these entries about places, and not only places mentioned in different languages, but also problems for identifying ancient places or debates. So this is a problem that we know how to represent ancient places. So not only the location, but also debate about the identification and location of a place. So there are really many interesting research questions in that sense, I think.
Yes, and I think that's where it will become clear as we move on, and Ludovic is going to show us some examples of the challenges of trying to locate places, whether they're classical or even just being mentioned in an 18th century text. So with that, I think unless there's any other questions that I don't happen to see here, why don't I'll hand it back over to Ludovic and we'll dive right in.
Yeah. Very interesting questions, and we'll see that it's not so easy to answer those questions and to have all the information on results that we wanted. So yes, we'll see how we can use this Perdido Geoparser library to geoparse text. So we will see how to load the dataset and how we can query these datasets based on metadata information, and later on information directly extracted from the text, thanks to the geoparser. So first we need, of course, to install the library from the pip command. So it should be quite fast, I think. Sorry for that. Then we also need to install Stanza as we will make some comparison of the results. So once the installation are done, we can directly import the library that we will use. So it's mainly some libraries, some classes from the Perdido library. So then the first things now is to load the data. So the data, as Katie told us, came from the Artful project, and we have here access to the volume 7 of the Encyclopedia. And you can have access to this link to the full to all the files, to all the TEI files of this volume 7. These files are directly loaded on the library, so we don't have to have a look. We don't have to go and parse the XML of these files. All of this is already done in the library, so we just have to load the dataset. And we have directly all the information as a structure and tabular data. So here all data are stored in a data frame, which is a specific Python object to store data. So it's like a table. You have column for information about your data. So here we have some metadata about each article. And each row represents an article. So here we have the name of the files, the number of the volume. So all the examples here will be from the volume 7. And then we have the number of the article. Then we have the head. So the head is the title or the name of the article. Then we have the norm class. So the norm class is the classification provided by the Artful project for each article. So we have some unclassified article, as Katie told us before. And then we have several classes like here marine or geography and so on. We also have the information about the author of the article when it's known. And then we have the text. So we have the full text content of each article. And this will be on this column or on these values that we will process the Geoparser. So first we will see that with some structured data like this, we can make queries and we can make some filters. So it's an exploring the data, sorry. Just with some basic queries and not on the text for now. So we can simply see how many articles we have, how much articles we have in the dataset. So here, for instance, we have more than 3,000 articles. So just using the shape attribute of our dataset object. And then as we have some metadata here, on the different column, we can query and we can filter the rows to get only some articles based on these filters. So the first one will be to filter and to get only the article of geography, for instance. If we are interested in geoparsing, that means that we want to create and to map these articles. So it can be interesting to first get only the article of geography. So here we just give you the list of the norm class that refers to article of geography in the Encyclopedia. So this list is hand made and is based on all the possible value for the norm class provided by the Artful project. And then I can query easily my data frame. So my data frame is on the dataset variable. And I can say that I want that the norm class column of these datasets belongs to the one string of this list. And I will get only the articles that are from the geography. So we can see the results here for the 10 first rows. And we only get articles from the class. Okay, so we can do others query. So for instance, we can query other metadata. So we have the authors, so we can ask and we can filter based on the author. So for instance, if I want to know how many articles are written by Chevalier-Joucourt, I can just specify that the column author should be equal to the value here, and the value is Joucourt. and I get more than 400 articles from the geography articles. So I had I don't remember yet. Yes, so here, sorry, I forgot this cell. So we have 489 articles of geography, and then among them we have more than 472 articles written by Joko. And we can also have the count for every possible authors in the dataset. And here we have the distribution, for instance, of articles per author. So, and we can imagine doing the same for all the metadata in our datasets. So this is the first interest to have structured data. So yes, I see the question from Gabriel about listing the categories. So actually, yes, we can also do a keyword search and search only for geography among the category. Yeah. We will see that we will see later keyword search on the text, but we could also perform this on this column. You're right.
Could I just add something there? So one of the interesting things about the categories is, this is a bit written a bit in the notebook, but there are multiple different kind of, historically, there have been multiple different ways of classifying this content. So one of the things that we had to be quite careful about was going and learning which classifications are actually about geography. And as you can see, there's often a kind of concatenation, right, of 2 or 3 classes together, like geography and history, geography and mythology, or even ancient geography and sacred geography. So that, we happen to have this list of norm classes lying around, and so it was easy for us to just throw that in here. But if you were searching and didn't know what already existed, you could try that out, certainly with keyword searches.
Yes, and we can say also that in among all these classes, the 2 main or the 3 main classes are the first one, so the geography and geography modern and geography ancienne, but all the other one have only 1 or 2 or very small amount of articles. So the main one are the geography and geography modern. The other one are very, very specific to only small amount of articles in the encyclopedia. So now let's go to the text. Oh no. Yes, no, not yet. Sorry. So, for instance, we can also filter based on the name of the article. So, for instance, if I want to get the author of the article named Frontignan, I can just use this line of code. So I just filter that. I say that the column head should be equal to Frontignan, and I want to get the author from this from the results. So here I saw that Jocourt the author of the article Frontignan. So this was for the query and requests by metadata. Now we want to search by text. So I can get, for instance, the content of one specific article. So if I want to get the content, the raw text of the article Frontignan, it's exactly the same query as before, but this time I ask for the text column here, and I get the results as a string. So I've got the full text of this article. Then just some example of query over the data frame to get, for instance, a keyword search. So it's exactly the same construction here. So I have my data set here. I said that I want to use and I want to filter over the text column, so over the text content of the article. And I want here, in this case, that the text contains the word France. So here I will get all the articles that contains France in their content. And we have here 2 239 articles containing France on the volume 7 of the encyclopedia. I can do exactly the same with any keyword that I want. So for instance, if we try with ville de, which is commonly used in the encyclopedia to describe places and to describe town. When they describe every city, they always refer to which country or which region they belong. So it's very frequent. So we can get all the articles that is ville de, supposing that the next word will be the name of the country of the region. So here we have all, and we can say from the extract text that it's almost all the time refers to a city or to a town. Okay, so Petite Ville de France in the case of Frontignan, or Petite Ville de France for Fumchim, etc., etc. We can also do some thematic search if we're interested by geography. So for instance, we can search for slavery. So I look for the word esclavage in this data set. So I only have 5 articles in this case. But then we can go deeper and see what's on those texts, try to map those texts if there are some places in it, etc., etc. We will see that later on.
I just want to jump in here before you go dive into the geoparsing. So one way to think of the utility of all of these different ways of searching is precisely to create a subcorpus that you will then go on to geoparse. So often, you don't want to necessarily process an entire text, right? Something as large as the Encyclopedia or some other kind of large corpus where you have many documents. You're going to want to refine that corpus in some way. And so these different ways of refining, either by the metadata, if you happen to have that in your corpus, or by the text itself, are the kind of is like the first step to getting down to a manageable subcorpus, which you can then run in the geoparser.
Yes, that's right. So let's then see some examples of how we can use the geoparser and what are the results. So the geoparser is something typical. It's in NLP and mixing NLP and GIS, let's say. So the pipeline, the NLP pipeline, is quite usual. We have a pre-processing step doing tokenization, sentence segmentation, lemmatization, and part-of-speech annotation, part-of-speech tagging. So in our case, in the case of Perdido, we use TreeTagger as a part-of-speech tagger. So it's not very adapted for historical text or ancient texts, but we don't have tools available for French and for ancient French, so or old French. So it's working pretty well. So we continue with it, but in the project we are working to find new other solutions with language models more adapted to the corpus. So this was for the pre-processing step. Then the main step of the geotagging is performed by a cascade of transducers, which is developed in the Unitech platform. So the idea is just to define some linguistic patterns or linguistic rules to recognize named entities on the text and to extract, for instance, other informations like spatial relations or some specific verbs and things like this. So here this tool is built with rules and made rules by experts. So it's based on lexic, dictionaries, and on linguistic patterns. So it's not made for the moment with machine learning stuff. So we can also compare this kind of methods with the new methods implemented in Stanza or Spacey that use deep learning and language pre-trained language models. And then at the end of the geotagging step, so it's just try to recognize named entities, let's say place names, person names, and so on. And then the next step is to try to geocode place names, to have a look into gazetteers or geographical resources to get geographical coordinates for place names. But actually, the geocoding step has two purposes. The first one is to get geographical coordinates for place names, and the second one is also to help the classification of named entities. So for some cases, the geotagging step is not able to make decision and to say if it's a place or a person. So we just add a MISC tag. And then during the geocoding, if we find locations for an unknown place, unknown name, sorry, unclassified names, then we can assume that it's a place. So it also helps the geotagging task. And as it is difficult for to have language model adapted for each state of the language or for ancient text, it is also difficult to get the good gazetteer or the best gazetteers adapted to the corpus, to the data. So here we have the same problem, and we can use in Perdido several gazetteers. So by default, it uses Nominatim, which query the OpenStreetMap database. So it's more contemporary places. We can also use GeoNames, which is also contemporary databases. And more recently, we can use World Historical Gazetteers and Pleiades, where we can find more adapted data for ancient places. But we will see that it's not so easy to use, and that the results are not what we expected. Okay, so I go a little bit faster on the TI. It's not very important as we don't parse the document, but we will see some examples, so I will go directly to the code. Okay, so getting started with Perdido. So the first thing is to get texts, as Perdido is not working with structured text or is not working directly on the data frame as we saw before. It's working over text, so we will extract some text from the data. And as Katie said, it was just the data frame can be just a way to filter and to get a subcorpus, a sub-dataset. So here it's what we say. We will get, for instance, the text of the Frontignan. Let's continue with it. So here in the content variable, I have the text as a string of the Frontignan article. Then I can create a Geoparser object from the Perdido library. So I imported the library before, and now I just create an object with it. I specify that I'm using the Encyclopedia version because Perdido has been initially developed for hiking description. So, and here we are using a custom version specifically for the Encyclopedia. Okay, and then I have the Geoparser, I have the content that I want to parse, so I can directly run the Geoparser over the text. So it can take some few seconds to run. And then I will have the results in the doc variable here, and we will see that there are several attributes or methods that we can call on this object. Okay, so now the process is done. So I can access all the results. So for instance, if I want to see the results as a TI XML, I can use the TI attributes. So here it's not very readable, but it's not the point. So all the information are structured, and there are a lot of details of information and a lot of details on semantic annotation on each token, if the token belongs to a named entity, which type of entity, and so on and so on. So not very important to go into the details, but we have the full structures of what had been tagged in this object, but we can access easily with all the attributes as we will see. So, for instance, as we did the geoparse here, we also have geographical coordinates assigned to place names. So we have an object, GeoJSON objects that only contain places. So here, for instance, we have the coordinates and the location for all the places that have been found in the text. For instance, we have Frontignan here with the coordinates here. We have also, for instance, France that have been found in the text. We have the entity Bas-Languedoc, Maguelone here, Agde, and Montpellier. For every one of these, we have the coordinates found in the gazetteers, and we hope with all the information. And we will use this to map the results just in a few seconds. We can also have a look at the results as a data frame. So, for instance, here we have a table with all the named entities that have been found in this text. So we have, for instance, Frontignan that we just saw in the GeoJSON. It's a place, and when it's a place, we have, when available, latitude and longitude. And we also have a column for toponym candidates when we have several locations that are found in the gazetteers for this name. And we will see, and we will talk about that big problem later. Yeah, so here is just a way to visualize the text as or the named entities that are in the text as a table. Then you have access to some methods to save and export the results. So, for instance, here I'm on the Colab. If I go to the files here, if I save the XML results, so it's the TI results, it will appear here. So here I can download the results, the TI results, and do other things as I want, and create a new corpus and go to parse this file and get what I want. The same just GeoJSON, so I can get the GeoJSON file and I can upload it on another tool to visualize it and so on. And the same for the CSV. So the CSV is the export of the data frame that we have here. But what is more interesting maybe for you is that we can see and we can display the results directly here in the notebook. So, for instance, I can show all the named entities that have been found, and I can show them directly on the over the text. So I have all the text, and I can highlight the named entity. So here I'm using the display C function from Spacey just to display the results. So I saw the question from Dankmar. So where did you get the gazetters from historical places from? So there are two gazetteers, as I said, that are more dedicated for historical places. That are all historical gazetteers. There are, I will add the link after, but you have the World Historical Gazetteers and you have the Pleiades. These two more dedicated for historical places, but with only small scope and only a limited amount of data. So they are not always the best solution, but more recent databases are not always also the best solution. So we will talk again about the gazetteers at the end of the tutorial. So yes, I was on the display. So you can display like this the different entities. So you have the loc. So the loc are the place names. So here we can see the place name. You have the MISC here that has all the other things. And something specific to Perdido is also to get what we call the nested named entity or extended named entities. So we have several levels of entities that can be nested in one another. So for instance, well, we have some problems about of display, but here we have France, so it's this one, and we have also Petite Ville de France. So France is a named entity that is nested in the entity Petite Ville de France, and we have the same here for Étang de Maguelone. So we have Maguelone, which is an entity, and we have Étang de Maguelone, which is another entity. So we have these structures, and we have high level or high granularity of level of information about the named entities from the text, and this can be used to disambiguate and to classify entities. For instance, here we know that thanks to this article is talking about a city, or for instance here we know that this entity here, Maguelone, refers to a small lake or small water. Yeah, sorry. Thank you. So yes, and we will see that this is a big difference with other tools, and that the other tools are only retrieving named entities like this, based on the proper names most of the time. And then we can also get the map, the geographical map of this article, so always about Frontignan. So here is the results of the GeoJSON that I showed just before. So we can see, which is interesting, that there are some errors, because Frontignan, if we read the article, is the small city of France, just something here, somewhere here. Well, yes, Frontignan, it's here. It's near Agde, near the Étang de Maguelone, which is here, and near Montpellier, which is here. Then we also found in the article France, which is located here. So it's not a point, but here France is located as a point. Geometry would be better, but it's like this. And then we have an outlier here. We have Bas-Languedoc. We have Bas-Languedoc located somewhere in Quebec. And this is the problem of ambiguity, of toponyms ambiguity, and the problems that a lot of places have the same name. And here we have, I don't know if you can read it, but here we have a small river called Languedoc. And so OpenStreetMap says that Bas-Languedoc is here, which is false. Bas-Languedoc is a region of France, just near the other places. But this is a case, this is an easy case that we can remove or delete this outlier and say, okay, the location of this article or the map of this article is something like this. So these examples works pretty well, and we will see other examples. So for instance, if we try another one, so we get the text again for Gesoriascum. So we have the text here, and we parse the content with this line, and then we will display directly the results. So again, the geoparsing process can take some seconds to run. The advantage of this method is that you don't have to load a very huge language model at the beginning, but each query can take some seconds to run. And the more you have named entities on the text, the more it's long because of the geocoding process. So for each name, I'm going to query the gazetteers. So it can take a while if you have a lot of entities in your text. So here you have the results. So we have places in orange, we have persons, and again, we have some MISC here. And we can see that we have some mistakes. For instance, here, Jules César is categorized as a place, which is a mistake, obviously. And the other one seems quite good. Yeah. And again, we can get the map of this article. And again, we will see that it's not so good. So we have here Grande-Bretagne, which is quite good. We have Jules César, which is here. Okay, good to know. And then we have Gaulle, Boulogne, and Bologna. Don't know if it's good, but I don't think so. So here we have the difficulty. We can clearly see the difficulty to geocode this text. So we found quite well the named entities, and we categorize them quite well. So we have the person's names and place names. But when we are trying to geocode and to find and to create a map, then it's much more difficult. So, and this is using nominative, so it's not very surprising that we can't find ancient names here because it's not very adapted. Okay, so now we can just try to compare and see what the other tools do for named entity recognition. So we will use two tools, Spacy and Stanza. So I will start with Spacy. So I just have to download the pre-trained French model from Spacy. Okay. So it should just take a few seconds depending on the internet connection. Then I import the library. I load the model. And then I will parse. So the same content, I will use the last article that we perform here. So the Geoparsing article. And I will parse it with Spacy, which is faster than Perdido. And then we can have a look at the entities found. So here we have the list of all the named entities found by Spacy in this text. And we can obviously also use the display-C function to display the map, just as we did with Perdido. So we can see that we have some differences. We have some things like here, geog, which is the class of the article that have been classified as a location. Then here we have a named entity without class. Here, yes, Caligula person. Okay, okay. This time Jules Caesar is a person and not a place, which is good. And then we have some small mistakes at the end here. So we have something quite similar with some small differences. And we don't have we just have this level of information. We don't have, as we saw before with Perdido, the nested named entities. So we will try the same thing with Stanza. So we just have to import the library and download the pre-trained French model. So it will take some few seconds. So these two tools are using state-of-the-art or the more recent advances in deep learning methods and using language models. So here it's pre-trained language model for French. So again, it's not very adapted for historical or ancient text, as is more contemporary French. I think that they are using like the entire web to train their models, so it's not exactly historical texts. So again, we can use or we can perform or we can train new models to try to improve the results depending on the corpus that you have. And then we can just run the process again, this time using Stanza, and we can go over the results just as we did. So again, we have the list of the named entities, and we can see also again that we have some other differences. Yep, we have some other differences. Morin is a location here. Petinger is a location. Voyer-la-Martinière is something else, etc., etc. So there are small differences. So these two tools don't perform the geocoding task. They only do the named entity recognition. So if you want to get the location of place names, then you can use the geocoder from the Perdido library or other library also that performed a geocoder. So here I will just show how you can simply use the geocoder from the Perdido. So we already imported the library. So I create the geocoder object, and then the geocoder just take the name of the place that you want to geocode. So I can run this cell. And I will get doc here, my variable perdido object, just as before for the geoparsing. So I have access to the GeoJSON attribute, and I've got the GeoJSON of the results. So here for the Lyon city, and I can get directly, or I can display the map. So here for Lyon. So we can apply, or we can use this geocoder over the place names that have been found by Stanza and Spacy, for instance. So let's do it for Stanza. So I can run again the Stanza parser over my content. Then I can get the list only of only places from the entities found by Stanza. And I will try to geocode the names that are classified as places by Stanza. So I just do a loop over the entities that have been recognized by Stanza, and I will just get the location. So, and I will geocode this list using Perdido. So I use my geocoder, and I give it as an argument the list of places that I want to geocode. So we can geocode either one place or a list of places. So here, as we have a list of several places, it takes more time. Again, it query OpenStreetMap for every names in the list, and then I can get the results as a map. So here it sees the geocoding results for the Stanza name city recognition process. So I have Grande-Bretagne, Boulogne, Boulogne-sur-Mer, Romain, so les Romains, Pottinger, which has been found as a place, Gaulle, and Morin, which has been classified as a place, but it's not actually a place, but there's a place called Morin. So this again highlights the difficulty and the fact, the difficulty dealing with ambiguities, toponyms ambiguity, and the fact that, well, a lot of places have the same name, but also names of other things that places can be a place. So it's difficult sometimes to do the classification thanks to this. So I don't know, Katie, if you want to say something about the comparison of the different tools, or if we go on.
Yeah, I think we can go on, and we can talk about some of that stuff at the end.
Okay, great. And if there are some questions, you can ask, and I can stop and try to answer the questions, of course. So if we come back to the use of Perdido, I showed you that we can use Perdido to geocode one text, but we can also give it a collection of text, a list of texts, and it returns a collection of Perdido objects. So we can experiment that. So I will, as the process can be time consuming, as you saw, we will test it only on a small sample. So I just select randomly 3 articles from the dataset. So here I come back to the Encyclopedia dataset. I use the sample method from the data frame and from the pandas library, which return randomly selected articles. So here I select only 3 articles from my dataset. So these are the, and so if, for instance, if I run again the cell, I will get others articles. So let's see with these ones. So I need to get only the text of these articles before doing the geoparsing with Perdido. So for instance, here, if I print the contents, you will see that I have a list only of texts. So I don't have a data frame anymore. I just have a list. This is just the index of the line of the row, but I have the list of the three texts of my subcorpus here. And I can give this list to the geoparser, and it will return a Perdido collection, which is exactly the same object as before, but this time with several objects inside. And we will see that we can also map and display the results directly from this object. So again, I don't know in this text if there are a lot of entities, so I don't know how much time it will take to run. Let's see. And after that, we will go to explore the encyclopedia with already geoparsed data sets. So because as the process can take times, you also have access to already geoparsed text, and we will see how you can use the results of the geoparsing to make queries and to make analysis on your text. So it's still running.
Maybe it's okay to move on.
Oh, it's okay.
Oh, there it is. Yeah.
Yeah, so now we can just go over all the three texts and show the results. So for instance, yeah, here you have the first article. We only detected two place names, which actually are not place names, so it's mistakes here. Here you have the second text, which is a short text, not very good examples, but that was not the point. And here you have the third text with more entities. So this one is better examples with a lot of place names, some cities, some persons' names, and so on. So exactly the same as before. And now we can map, for instance, these three texts together. We can query these three texts and so on. We will see that with the already parsed corpora. So yes, I don't need these cells. I forgot to remove this cell. Sorry. So just as we did at the beginning, we can load data sets, and this time we will load the already parsed volume 7 by Perdido using the Pleiades gazetteer. So I just load the data set in Python objects. It should be okay, yes. And then I can also open it as a data frame. So here I have one row per article. And then we can see that we have new columns that we didn't have before. So as it is already parsed, we have some more information. So for instance, we have the number of places that have been located in the text, or the number of persons' names, the number of events, and so on and so on, and the number of locations coming from the geocoding step. So this is using Pleiades, so very specific gazetteer, and we will see that there are not so many results that are found with this gazetteer for this dataset. So again, we can also perform a keyword search as we saw before. So for instance, I can, if I want to get all the documents or all the articles here that contains the name Rome. So I have 72 articles with the Rome in their text, and we have the information. We have the name of the articles and the number of places that are located, and so on and so on. So we can filter again, and we can select. We can select a small corpora and go deeper on the text, only on small amounts of texts. So it's a way to help the analysis of the corpora. Maybe Cathy, you want to say something here, or I continue?
Yeah, let's get to the Funérailles des Grecs example.
Okay. Yeah. So I do the same. I just filter and I just say that I want to get all the rows where the column head is equal to the value funérailles des Grecs. So I want to get actually the article funérailles des Grecs, which is this one. So I have the metadata for this one. And I can also directly show the results of the geoparsing, as it is already parsed, obviously. Well, yes, like this. So you have person's name again, you have place names. You don't have a lot of place names. And what is interesting is if we try to geocode this, oh no, it's not here for the moment. It's after that. So yeah, we'll talk about that later. So what is also possible is to filter based on several articles. So if I want to select several articles at once, for instance, here I want 2 articles, Genève and Funérailles des Grecs. So I can do a query and get the collection of the 2 articles. So this kind of queries were already possible with the non-geoparsed texts, but what is new is now I filter based on the number of places that have been located in the text. So for instance, I can say that from my data sets, I want only the articles with places inside. So with where the value of the number of places is greater than 0, actually. And if we check here, for every row we will have a value here greater than 0 for the number of places. So this was not possible with simple query or simple keyword search. So this is just because we perform the name entity recognition and the geotagging that we can filter based on the name, on the number of places that are in the text, even if we don't know what places it is there.
Yeah, and I'll just add in there. So I think this is a really important kind of moment where you can begin to see how there's a potential for error to be introduced at multiple points along the line of trying to get to mapping place names mentioned in a text, which is theoretically the goal of these tasks combined, and it's quite simple to see that there's error in the number of places that are being recognized. We've seen that sometimes places are not identified in the text, or they're misidentified as other types of entities, in particular people or miscellaneous. And you can see quite clearly here that the number of places rarely corresponds to the number of locations or the number of located places. And that is really a function of, as Ludovic has said, the content of the gazetteer, but also the way in which you query the gazetteer. And I think we might see an example of this below.
Yeah, so, well,
in fact,
here it's,
just here.
it's exactly the same, actually. We just query on the number of locations, so we can get the list of articles that have locations. So when the difference between number of places and number of locations, number of places is just named entities classified as a place, and locations are the geocoded place names. So that's here we only have 12. So using Pleiades over the volume 7 of the Encyclopedia, we only have 12 articles that contains geolocated place names. So it's very, very few. But this is actually, this can be improved because of the way of how we query the Pleiades databases. So this is only possible for in the Perdido library for a few days, so it will be improved. This is still an ongoing project, so it will be improved in the further versions. But well, it's it says something about the difficulty to find resources adapted to your corpus. Here, the gazetteers are not adapted. So, or if we are only interested in a very specific or in a very small area, we can find maybe a gazetteer adapted. But in our case, it's very difficult here dealing with the encyclopedia articles. Yeah, so we will see some other examples that highlight these facts. So, for instance, if I change and I get if I get the article's name Gabal, so I get the metadata, but I want also to get the text. So it's a short article. So Gabal, which has been found as a location, is a god. Adoré à Hermès, Heliopolis, and so on. So here we have actually two place names, Hermès and Heliopolis, but Heliopolis haven't been recognized as a place. And if we go and have a look at the GeoJSON to know if those places recognized have locations, actually they haven't. So here we have named entities recognition that says that there are two places, but we haven't found any location using the Pleiades gazetteer. But we can perform and we can try to geocode Heliopolis. So for instance, the Heliopolis here, we can try to geocode and using OpenStreetMap to see if we have some results for Heliopolis, and we can get a maximum of 10 results if there are more. And I can display the map for Heliopolis. So this is a map for the 10 first Heliopolis places found in OpenStreetMap. So all the dot refers to a place called Heliopolis. So we can see that we have lots. We think that none of them is the one that interests us, but we are not sure about that. But well, you can clearly see here the difficulty to geocode place names.
Yeah, and I'll chime in here, and then I can just start quickly to say something about toponym disambiguation with network analysis, and then we can wrap up if that sounds good.
Yeah.
So as you can see, trying to locate historical places on top of trying to identify those places in the text is incredibly complicated. The lack of availability of historical gazetteers for particular regions and particular places is something that scholars have been aware of for a long time. And there's an excellent community of people building these resources. And a lot of them are now being sort of cataloged, so to speak, in the World Historical Gazetteer Project, which is very much a kind of work in progress itself, but highly recommend that you check it out. And over time, our ability to locate these places, at least the ones that can in fact be located, they lack the kind of ambiguity that just simply means that we'll never be able to locate them, either because they're mythological and don't actually exist on the earth, or because we simply lost enough knowledge that we can no longer accurately locate them, which is something I imagine that classicists are quite familiar with. So given these challenges, which we're continuing to work on, the kind of thing that we wanted to try out, both as a method for helping us to disambiguate places in terms of kind of getting a rough location for them that would help us identify the best candidate. For example, in Heliopolis here, you can see there are multiple candidates for that text string. So what additional information can we use to help refine the decision of picking the best candidate? That was something that we wanted to use network analysis to help us do. And we do that by virtue of, if you want to scroll down just a little bit more, We do that by virtue of showing how place names are related to each other in the text. So if any place name is actually the title of an article, it's a head word, as you've seen us search for various head words in the records that we're looking at in Volume 7. If that place name is written in any of the other geography articles, it establishes a link between those two instances of that place name. And that is effectively the basis for the graph that you're looking at. So the nodes are the place names that are head words of geography articles, which also reappear in other articles, and the edges connecting them are the sort of demonstrate the fact that a head word is cited or referenced in another article. And so this is what I was talking about at the beginning, where we're using this to establish topological or qualitative relationships between places rather than using geographical coordinates to understand relationships between places. And we can use these qualitative relations to, in a sense, establish a kind of proximity or so if France is cited in an article about Europe, then we know that if we can locate Europe, then we can create an approximate location for France, for example. But the other thing is that this kind of visualization is just a really exciting alternative complement to geospatial mapping. This is another kind of mapping, as a lot of people have been using in the digital humanities for a long time. So we're very excited about this opportunity for network analysis to help us work with information that, in fact, might never be able to be mapped in that more traditional sense. So we're very excited about this, and we welcome any questions that you might have, or indeed, if you have ideas for using this kind of analysis in your own work, we'd love to talk to you. So I think since we've run over, we might not get to the discussion questions there, but if anyone would like to respond to those briefly, we'd be happy to chat for a few more minutes, I think. Okay.
Yes, of course. So we still have definitely at least 10 minutes, so we can definitely discuss these things. So first of all, thank you very much, because really it was great to see these practical problems that we know we have today. So really practical problems working with historical data. So it was great. I don't know if there are questions, and I would just to start the discussion with an interesting comment by our colleague and friend from Brazil. So exactly, instead of perdido, maybe achado or trouvé. Well, let's stress the positive, okay, results. Of course, we have a huge amount of problems, we know that. I'm working on entities for ancient Greek, we know, but we already find interesting results, and also from a methodological point of view. So to end with positive note, okay. But of course, we're working with the lost past, so that's the thing. I don't know if there are questions. I have questions, so I don't know if I don't know if Gabby, you have questions, or please in the audience you can write your questions. But
I just wanted to comment. Gabby, you made that comment about the Heliopolis and the accent mark, right? And I think that is, as Ludovic was saying, the way in which you query the gazetteer, right? Having an intelligent, flexible query is just as important as the whether that content is in the gazetteer at all. And so it can be deceptive that people might think, oh, this gazetteer is actually not the best fit for me, when in fact it's more about the string, fuzzy string matching and things like that need to be tweaked.
Yes, I think that's the problem, because I don't know how many French places has Pleiades. Of course, maybe you can use the Latin form. For example, I have the problem with Greek, because Pleiades still, of course, we know depends on traditional printed resources, where mostly we have Latin forms or English forms, as we know. So I think that this is a problem definitely also for French. And Heliopolis is an example. Yeah, please.
Yes, but I think I said that. But here the Pleiades have just been added in the Perdido a few days ago, so the results can be of course improved and will be improved very soon. So we will improve the way we query the gazetteers, but it was just to highlight the difficulty of finding those places.
Yeah. We really, made things look quite difficult, but the comments are correct that everything here is actually truly astounding and has helped us do an immense amount of work. So we've highlighted the negative, but which is not to say that this work is really truly state of the art for historical text searching, and it's incredibly exciting to work with it.
Yes, no, exactly. It's not a negative or positive. This is where we are today. And on the other side, stressing the trouvé, you are adding new forms in a new language, which is, I think this is one of the goals of your project. So you want to disambiguate to find these places, but on the other side, you offer to the community new forms in another language. So a balance between the two. And I have a few questions. So going at the beginning, when you said we are lucky because we have the Encyclopedia in a structured form because we have TI-XML files. A question, I assume those files are the result of OCR, and the structure basically is, I assume that you have single entries in sort of paragraphs, and then of course within each entry we know that then you have to disambiguate many things, identifying different languages, and then as you were showing, of course, finding places, persons, etc. So this is just for our students to see. Of course, you say we are lucky. Yes, of course, definitely, I understand, because to have the XML files is a good starting point. But by structure, I mean, I assume is an OCR output with
no, this is manually transcribed text.
Okay, that's interesting.
And
exactly.
And that's why it's such high quality. We're incredibly lucky to not have to account for OCR error.
Yes, exactly. And my question was about that. But if you have, this is a well-known discussion about copying the text.
But if anyone is interested in Caroline Parfait and a whole group of people, including Glenn Rowe, are working on precisely issues around OCR error, evaluating OCR error in French NLP task performance. So you should check out their work.
Okay, but this is good for you. I mean, we know another discussion, of course, how can we sustain OCR post-correction? We know that for classical languages, for example, for Greek, we get excellent results, but of course, this is a well-known problem. So definitely, so you are, let's say, lucky to have these text. And another question I have is about, at the beginning you said, so basically we are creating a subcorpus. So you identify, let's say, not only patterns, but a language, for example, Petitville de France or Étang de Maguelone. So, I mean, again, so of course, you know the corpus you are working with. In some way, you are what you are looking for. Well, not really. But so as part of the project, you are trying to build a language to create this subcorpus, if I understand correctly. And this is also what we get, for example, when we are showing that for a location, we can find something like Petitville de France, which is good because Petitville can help us to further disambiguate the results. Is that correct? So it's part of the project to create a sort of, let's say, a lexicon for this subcorpus. And do you document this? I hope that my question is okay. Yeah.
Do you want to answer that, Ludo?
Okay.
Yes. I can start. Yes, actually, it's part of the project. I don't know if it's exactly that, but it's part of the question and of the objective that we have is to try to characterize and to see how the discourse evolved in the different encyclopedias. So how to check and to confirm or not, to see how they talk about places in the Encyclopedia and they talk about places in the more recent encyclopedias. So we'll try to focus and to see what are the information in geography articles that are very specific to geography and to this kind of articles. So yes, that's part of the project.
Yeah,
yeah. There's I was just going to say, Denis Vigier has been leading on a lot of that work, and it's been really exciting to really see just how structured that information actually is in these texts, and how it carries over from a lot of the 17th century dictionaries that we're also starting to look at. So just the nature of the history in which this information gets printed is really fascinating, and these phrases are really like these kind of like key phrases that stick over time. It's really interesting.
Okay, yes, of course, this is interesting because our perspective is a modern contemporary perspective. You're working with historical text. Gabby, please, you have a question.
I have a very practical question. I mean, thank you for this, especially for that notebook, which I was following through very, very excitedly and clicking on all the cells. And I just wanted to ask, are you planning to leave that notebook online on Colab so people can use it in future? Because one thing that I found quite fun with it, and I hope students will too, is that even if you don't understand the Python, you can tell what each cell does, partly because you click on it, you can see it happen, and partly because they've told you really, really helpfully in the notes. And in some places, you can go in and change things. So, you know, where Ludo did the search where he said, find me all the references to Rome. I went in and changed it to Athens. I went in and changed it to, in fact, it wasn't Rome at all. That was one of the things I changed it to. But you know, and you know, various other places. So you can use this to actually do mini research on things, and then see what map it throws up, see what it gives you in OpenStreetMap, see what it gives you in Pleiades, and so I think that'd be something really fun for students to try out themselves. You know, even if they you know they wouldn't be able to write this themselves, and they might not even be able to customize it much, but just changing the keywords, I think. I mean, I plan to keep on playing with this for the next hour or so.
Yeah, thank you. Yeah, it will stay online. The GitHub repo will stay open. The library will be improved, but I think that all of this will still works. And as you said, it's not limited to the exercise and to the things or the keywords that look for really usable. So you can use it, you can modify, you can make the query you want, you can load your own data. Yes, it's totally open, and it will still be available. Yeah.
And if you find interesting things, we would love to hear about it.
Well, definitely, sure. I know, Katie, that probably you have to go, and we are a bit over time now. So if you have to go, I understand. So, but we are finishing now. So, well, thank you. And again, for our students, yes, please use the notebook to understand practical problems that we have today, and then you can discover interesting things. I didn't know that we have so many Heliopolis in the world, for example, or this is interesting. Okay, this is not what you're looking for, but still, you get other place names with the same name. Okay, now, unfortunately, we have to stop the session, but definitely there are many other interesting questions, and definitely I'm sure that we will get back to you for this really fascinating project. Okay, again, the class outline is in GitHub. You have the video and then also the exercise. Next week, we have another session. We go back to talk about museums, digital data and metadata about museums, and this is our 10th session. Then we will still have one session on July the 7th. But for now okay, our session is over. Thank you, Katie. Thank you, Ludovic, for your time, for this wonderful session. And thank you to our audience. And so good night and see you next week. Bye. Bye-bye.
Thank you very much.